In this lesson, we're going to talk about perpendicular bisectors. So just remember what a perpendicular bisector is. It has to be two things. So it has to be perpendicular and it has to bisect. So perpendicular means that you're going to have a line or segment or array that's intersecting another segment, and it's going to be perpendicular to that. So if you look at the picture here, this would be the CD would be the perpendicular bisector of segment AB. So it's because it's perpendicular and it's bisecting. So it's a line or a segment or array that has to be perpendicular to the given segment, and it has to intersect at its midpoint so that it's bisecting it. So this point right here, point F, is going to be the midpoint. Now keep in mind, you can't bisect a line, so perpendicular bisectors will only bisect segments. So you have to have a segment to do a perpendicular bisector. And then the bisector itself can be a line, or it could be a segment, or it could even be an array. So the two conclusions, I just want to write like the shortened versions of these. So if you have a perpendicular bisector, there's two conclusions you can make. So one of them is that you have right angles. So because it's a perpendicular line, so perpendicular bisector implies right angles. So that's one conclusion you can make. And a second conclusion you can make is that a perpendicular bisector implies two congruent segments, and that's because it's intersecting at the segment's midpoint, which means you have two congruent parts. So these are going to be things that we can use when we go to solve algebraic problems. So let's go ahead down and look at this first example here. So this first example, or this theorem down here, is saying that whenever we have a perpendicular bisector, so we know it's perpendicular to the original segment, we know that it's cutting the segment in half, but there's also a property that says the perpendicular bisector is going to be, any point on that perpendicular bisector is going to be equidistant from the two endpoints of the segment. Now remember, equidistant, that means equal distance. It sounds like equal distance, so it means the same distance away. So that means if I'm looking at point C, since point C is on the perpendicular bisector of AB, this distance right here, so I'm going to just mark it, is the same as this distance. So C is equidistant from the two endpoints. That's the definition of a perpendicular bisector. So any point on the perpendicular bisector will be the same distance away from the two endpoints. And when we get to the constructions, you're going to see that's actually how you do the construction. So that's what this is saying. All of those distances are equal because all of those points are on the perpendicular bisector. So really there's three things. The definition of a perpendicular bisector, it's perpendicular to the original segment, it's bisecting it, and the theorem that any point on the perpendicular bisector is equidistant from the endpoints. So let's go ahead and look at these examples here. So the first example is saying that we have a perpendicular bisector. So remember, that means we know two things. We know that CD is perpendicular, so I can draw my right angles. I also know that it's bisecting, so I know that these two parts have to be equal. Now notice I only marked the parts of the segment, not of the perpendicular bisector. So it's important that you read these carefully. CD is the perpendicular bisector of AB, so that means AB is the segment that's being bisected. So that's why I know that those two parts are congruent. It does not mean that CE and DE are congruent. That's not true. It could be, but we don't know for sure. And then, so that's the first two things that you would mark. The third thing is that point C is equidistant from A and B, and point D is equidistant from A and B because of that last theorem we just talked about. So if we look at what's given to us, it says AE is 3x plus 25, so we can label that. And BE is 4x minus 13. Well, in this case, they want us to find AB, but before I can find AB, I would have to know what x is so that I can plug it in and get a number for AB. So the first thing, since you have two parts and you know that these two parts are equal, we're just going to set them equal because the parts are equal. So part 1 equals part 2, since it is a perpendicular bisector. So I'm going to just write perpendicular bisector implies two congruent segments. Now I don't need to mention the right angles because it's not going to help me solve the problem, I'm using the fact that I have two congruent segments to set the two parts equal, so I don't even need to mention the right angles. So that means all I'm going to do is set 3x plus 25 equal to 4x minus 13 and solve it for x. So I'm going to bring the 3x over, and I'm going to add 13 to both sides. So that means I'm going to get 38 over here and x on this side. So x equals 38, but I'm not done because it says to find AB. So AB, so this is the first part. Second part is to find AB. AB is the sum of these two parts here. So what I'm going to do is I'm going to plug in 38. And when I do that, I get 139, which means this part should also be 139, but you actually want to plug it in and make sure it's a good way to check. So when you do that, you end up with 139. So that means AB is going to be 139 plus 139. So AB is going to equal 278. So that's using the fact that perpendicular bisector gives you two congruent segments. The second example is saying that AC is the perpendicular bisector of BD. So AC is the perpendicular bisector of this segment here, which means these two parts would have to be congruent because BD is the thing that's getting bisected. So see how it says bisector of BD? That means BD is the bisector. And then it means that you have right angles here. But it wants us to find AD. So if you look, you're trying to find this distance right here. Now this is not one of the parts, so I can't just put the parts equal because I don't have anything on the parts. But if you remember the property that any point on the perpendicular bisector is equidistant from the two endpoints, that would mean that point A is equidistant from D as it is from B. So that would really mean that these two lengths are going to be the same. Let me put two slashes since I already used single slashes. So these two distances have to be the same because point A is on the perpendicular bisector. So I'm just going to write that. A point on the perpendicular bisector implies that the point is equidistant from endpoints. So what that really means is that AB is equal to AD. The distance between these 2 points is equal to the distance between points AD. And that's because of that last theorem. So that just means I can set these two equal. So I can say that 7x minus 6 is equal to 4x, and then solve it for x. So I'm going to go ahead, I'm going to just bring the negative 7 over. Keep the negative 6 there. Make sure you carry down that negative with the 6. So subtract these, you get negative 3x. Divide both sides by negative 3. You end up with positive 2 for x. Now the problem said to find AD, so this was really the first part. The second part then means plug in for AD. So 4 times 2, so AD is equal to 8.